This is the elastic collision with two objects of different masses. The mass of object 1 is 0.409 kilograms, the mass of object 2 is 0.214 kilograms, and the velocity initial is 0.588 meters per second squared. We use the equation velocity final of object 1 equals mass of object 1 minus mass of object 2 divided by mass of object 1 plus mass of object 2 times velocity initial. When you plug the numbers into the equation, we get a velocity final of 0.184 meters per second squared.
Stop it. This is an elastic collision where the mass of object 1 was equal to the mass of object 2. The mass of both the objects was 0.214 kilograms. The equation that we used was velocity final of the second object equals 2 times the mass of the second object divided by mass of the first object plus mass of the second object, all multiplied by velocity initial of the first object. Velocity initial of the first object was 0.554 meters per second. When we plug this all into the equation, we got the final velocity of the second object to be 0.554 meters per second. This is different from the data in the video because we waited too long to calculate the final velocity. This created a huge error. The velocities were the same because the masses were the same. Gotta click it again. This is an inelastic collision where mass 1 was greater than mass 2. The mass of object 1 was 0.409 kilograms. The mass of object 2 was 0.214 kilograms. We plugged those into the equation Vf equals m1 divided by m1 plus m2 times velocity initial, and the velocity initial was 0.362 meters per second. Plug that into the equation and we got the final velocity to be 0.23 meters per second.
Right, and then make sure when we get the final velocity, you gotta hit it again, and then hit stop. The elastic equation between two objects with the same mass. The mass of the objects are 0.214 kilograms. When we use the equation velocity final equals mass object 1 divided by mass of object 1 plus mass of object 2 times velocity initial. The velocity initial is 0.404 meters per second squared. When we plug the numbers in the equation, we get a velocity final of 0.2 meters per second squared.